So now I'd like to try to pinpoint two take-home messages before introducing last talk. We are anytime between March 1st and April 1st, bud break is observed, and the vines start growing at a very, very fast rate. We are into the grand growth. Grand growth lasts typically up until 400, 450 growing TV days. After that, it slows down. How do I know that? Well, it's because papers have been actually trying to mathematically find the relationship between what you see here is the civil calendar, and what you see here on the y-axis is the amount of light being intercepted by the plant. So if your ground is completely covered by leaf area, 100% of the incoming light is being trapped within the canopy. In this case, you see that before bud break, 0% of the light is being trapped, and as leaf area develops, where you have an ever-increasing percentage of incoming light that's being trapped, and that's going to be fuel for transpiration. And then a plateau is being reached. Okay, so you can still irrigate your plant. The impact at boosting leaf area growth is going to be much less during that phase than during that phase, obviously. So now, what happened when we have a drought? Well, when we have a drought, the vine wakes up earlier, and typically what happens is that this whole leaf area dynamics is shifted towards your left, which means that when we hit this plateau, which will correspond to the maximum amount of incoming light trapped within the canopy, will probably be before the solstice. If we are before the solstice, that means that the vine is going to experience a wider period during which the climatic demand will be at its highest level. Which means that this tiny shift towards your left, we are talking about a few days, 10 days, maybe 2 weeks, will have a tremendous amount of consequence, because during that time where transpiration peaks, you really speeds up the rate at which water is leaving your plant compared to where you were the year before. So this little change here will have a tremendous impact later on during the season, because you are going to hit the bottom of your root reservoir earlier. So I thought that was important to have in mind. What are the carryover effects of early bud break as far as shifting towards the left, the moment when you hit the maximal leaf area transpiration? So this model was published in 2003 and is true only under one condition, that there is a limited soil moisture supply. And keep that in mind when Lars gives his talk, because he's going to show you how a plant, given that it has all the water it needs in the world, responds very tightly to heat accumulation. Okay, so again, now to see how 2014 affected the rate at which leaf area develops, I did these very simple graphs. This box here represents the amount of leaf that needs to develop in order to reach the top wire. And you see that at 200 growing degree days, we probably fill 50% of our box with leaf area, and around 400 growing degree days, 100%. That's rule of the thumb. Of course, it varies from side to side, but big picture, that's kind of what we are aiming for. So if we want to characterize 2014 vintage and understanding how the precocity of this vintage is actually affecting the rate at which leaf area develops, well, we'll just look at what it is when we reach 300 growing degree days. So typically when 75% of the leaf area is expected to be developed, we were on May 4th in Paso Robles in 2014, whereas in 2014, yes, whereas in 2010, that same point in the life of leaf area was reached 20 days later. So now you connect the dot with the model. The impact of the warming of the temperature is such that we reach full leaf area transpiration 20 days earlier. So you have 20 more days to account for a fully transpiring vine. So that's looking at the historical data. Now let's look at the spatial variations. Here we look at the site in Paso Robles where we observe the highest heat accumulation during the vintage versus the one where we observed the coolest heat accumulation. And this is fairly surprising because typically when we look at that graph in Bordeaux or even in Napa, we observe by the time we reach 300 growing degree days or 400 growing degree days, so 75% here of your leaf area is expected to be unfolded, there are only 5 days of difference, which means that at least through the data that we've been able to look at, there are very little variations from site to site. To give you some perspective, in Napa, between the coolest and the warmest site, we are looking at 3 weeks difference. In Bordeaux, we are looking at 5 weeks difference. Okay, so far we haven't seen such a very strong footprint of spatial heterogeneity at speeding up or slowing down the rate of leaf area development. Okay, so now what does it mean really when we look at vineyard water management? What you are seeing here is on the x-axis growing degree day accumulation. And on the y-axis is the amount of water used by the plant. We could have expressed it in terms of gallons per vine, in terms of inch per square meter of ground, or in terms of percentage of ET. Okay, just keep in mind that the percentage of ET is just a way to monitor the volume of water lost by your plant. And you see on the same vineyard, coming from the from the warmest area in Napa, so we don't have enough historical data from Paso Robles to have this graph yet, but I wanted to give you a background. VSP, Cabernet Sauvignon, you can see that after a wet winter, as leaf area develops, we consume more and more water, obviously. And then when we reach the plateau, you see that the vine water use stabilizes around 50% of ET. That means that to fully satisfy its water needs, the plant needs to use a specific amount that is directly proportional to the climatic demand. That same plant, after a drier winter, because the lack of moisture in the root system reduced the leaf area, stabilize its fully transpiring level of water at 30% of this value. Again, you see here a different impact of the lack of rain during the winter. It reduces the amount of water the vine needs to function. So, and that starts to be counterintuitive because then that means that a vine that experiences no stress in 2014 would need less water. This is good news because that means that we can potentially reduce our irrigation even in a time of drought. And I will elaborate on that to show you how we can actually quantify the water savings that could be achieved even in 2014. So keep that in mind. The maximal amount of ET your vine needs is vintage dependent. So it's not as simple as coming to, okay, I have my recipe, my vineyard needs 50% every year, I need to refill my irrigation with 50%. No, you have to actually respect the plant. Leaf area architecture sets up this amount of water that the vine needs to be fully satisfied. Yes?
When you say ET, relative to a lot of grass, or you say crop or growing back?
No. So it's ET reference. So that's actually a way to compare apple to apple where we are in Bordeaux or in Washington or in Napa. It's coming from a weather station, and actually this ET is computed by looking at sun, temperature, wind, and relative humidity. Thank you for clarifying. So if now we look at not the thermal time, but the civil calendar, you see that not only did we reduce the maximal amount of water the vine needs, we also hasten the onset of when this maximal amount of water is hit. So there are two effects. The first effect is in a drought, the plant will naturally require less water to be fully satisfied, but satisfying those requirements will show earlier during the season. Okay, so with that understanding in mind, let's look how it looks in the vineyard. So this is 2012, this is 2014. Those pictures are taken from underneath the ground using a fisheye lens. Why do we do that? Because then when we plot the sun trajectory over it, we can really precisely nail down the amount of photons. The photon is like the fuel for the plants to give the energy for water to be vaporized into the air. You see how it looks. So it's not very obvious, but the main point is that the porosity of your canopy is being deeply impacted by the winter drought. Now, if you look at a vintage where we had a shoot length measurement in 2013 versus 2014, this picture was taken at 300 growing degree days. So remember, when we are expecting to have reached 75% of our maximal leaf area, you see the drop. So roughly 15% of shoot length is reduced due to the lack of water during the winter. And this is in a moderately stressed vineyard. If we look at a vineyard where actually the situation is much more severely limiting, you see two things. You see that the knocking off of the shoot length is much more dramatic. We're looking at 50% of decline in terms of shoot length at the same thermal time. You can also see that the canopy coloration is a little bit more yellow. Remember, I was telling at the beginning that less nitrogen could be expected if we have less microbiological activity. Well, that translates with less nitrogen in the leaf, and therefore the leaves are more pale. So we now start to see the confirmation in May of what we were kind of anticipating in February. So the take-home message at this point is the following. We see that the values of the maximal ET, the maximal amount of water the vine needs, is vintage dependent. It depends not only upon water supply, but also upon nitrogen supply. And a take-home message for 2014 is that the peak value for maximal vineyard water use was reached earlier, even if it was lower. We'll see with Lars that this say can be challenged when the vine unfolds under unlimited soil moisture condition, and I think actually Martin also showed a great example of even in a time of drought, you can have, due to high irrigation, you can completely override the effect of the vintage. And the take-home message is that when you are in such arid condition, human practices can have a very, very strong footprint on the vineyard physiology. So, because Lars is going to speak about the relationship between leaf area and water stress, I thought I should spend 2 more minutes explaining to you what we have observed about monitoring water stress while looking at the amount of water that flows through the plant. So just a few conceptual background. What I'm going to track here is the percentage of ET used by the vine derived from sap flow. Okay, so we are just looking at the vine as if it was a bunch of pipes articulated together, and we are only monitoring how much water is flowing through this piping system. And this is what you see in a vineyard where no irrigation is applied. You see that the amount of water increases with time until it reaches a peak, the peak of leaf area. And then you see that because soil moisture declines, instead of satisfying the same level of water use, less and less water is actually feeding the canopy. That's when stress unfolds. Until balance is being reached, and you see here the vine, after reaching 60%, stabilizes around 40%. In 2014, as we've discussed, leaf area unfold, the vine stabilizes, but because it needs less water, it can actually maintain its water consumption until later. So at this point, I'd like to ask you, where do you think the vineyard is under the most severe stress? Are we talking about more stress in 2012 or more stress in 2014? Pretty hard to say, actually. Because what you really want to look at is the relative drop from the maximal amount of water the vine uses versus the amount of water the vine uses now. And I'm not discussing 2013, but you have a vintage in between. Well, in order to address this very question about stress, you need actually to calibrate what we call the crop coefficient of the plant, the dry soil crop coefficient of the plant. And that's precisely what the water deficit index that's going to be monitored here aims at looking at. So if we would look at 2012, once the canopy reached its maximal size, the transpiration is unlimited and we satisfy 100% of the vine water needs. And then as soil moisture declines, well, we satisfy less and less of the vine water needs, and then we stabilize around 50%, which is an acceptable level of stress for a plant before veraison, because at this point, photosynthetic activity is only moderately reduced. So we know we can tolerate that and irrigate when we get below that level. If we now look at 2014, even if the canopy is smaller, and that's when it's counterintuitive because the first instinct is to say, oh, my canopy is smaller, then I am more stressed. Well, you see that it's not, because actually, because leaf area reached its peak earlier, you fully satisfy the vine water needs earlier, but the plant is more easily able to maintain the need of its canopy. And you see that the drop, relieved here by an irrigation, is more moderate. So that's counterintuitive, but 2014, in some situations, could be less stressful in terms of water stress than 2012. And that's just because there is this tight interplay between canopy size and amount of nitrogen into the canopy. So keep that in mind when you try to connect the point between the size of the leaf area and the celerity of the water stress. So I thought with that introduction, I could remind you what is the goal of water deficit index, is to focus on the plant only, is to really remove from the equation the impact of cover crop transpiration, to remove the impact of soil evaporation and only focus on the plant, and every year readjust the vine water needs according to plant size and its nitrogen content. That was my last take-home message. And I think at this point, what we can say about the 2014 vintage is that warmer and drier condition pre-bud break set the stage for an earlier phenology. The fact that it was warm during grain growth set the stage for a good and early leaf area growth. The potential for a less or more severe water deficit depending upon your irrigation schedule. And again, it stresses the effect that the winemaker decision can have on the fruit composition. So at this point, I thought it was going to be interesting to have Lars' view on our vintage description, because I have looked at vineyards that were on a small scale where deficit irrigation was pushed to an extreme. Lars will present results that are looking at larger vineyards where actually irrigation started in January. So Lars, thank you for sharing your views on how the irrigation practices can actually affect leaf area growth dynamic and later on set the stage for stress.